and bases. Let's talk about that.
So what are acids? Acids tend to be sour, frequently burns your nose, or very sticky, like lime. Or vinegar. And these stuff are usually found in your homes. Acids have a low pH level and reacts with metal, and when a common indicator is added to an acidic solution during a titration, the solution stays clear.
Good job. So what is a base? So bases tend to be very, very bitter, like baking soda. They also tend to be very slippery, like soap. Very slippery. Other bases that can be found in your home are toothpaste. This is Colgate. Shampoo in your shower, and Clorox, also known as bleach. So bases is an electrolyte, and they have a high pH level, and when a common indicator is added to a basic solution during titration, it turns pink. Oh, there's another type of acids and bases, which is
Amphoteric,
which means that they're both acids and bases combined. Another example would be water.
H2O. Strong acids include hydrochloric acid, hydrobromic acid, nitric acid, hydriodic acid, perchloric acid, chloric acid, or sulfuric acid.
So the 8 strongest bases are lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. So these are the 8 strongest bases. What she said, the 7 strongest acids.
Acids are named based on their anion, the ion attached to the hydrogen. In simple binary acids, one ion is attached to hydrogen. Names for such acids consist of the prefix hydro, the first syllable of the anion, and the suffix "ic."
Complex acid compounds have oxygen in them. For an acid with a polyatomic ion, the suffix "ate" from the ion is replaced with "ic."
Polyatomic ions with one extra oxygen have the prefix "per" and the suffix "ic."
Polyatomic ions with one fewer oxygen have the suffix "us." Ions with 2 fewer have the prefix "hypo" and the suffix "us."
Strong bases with OH groups are named based on their ionic compounds.
Weak bases are named like molecular compounds or organic compounds.
So what is an Arrhenius acid and base? An Arrhenius acid is a substance that dissociates in water to form hydrogen ions or protons.
So an Arrhenius base dissociates in water to form hydroxide ions, OH negative.
And an example of an Arrhenius acid is HCl, which is when it dissociates in water to form hydrogen and chlorine ions.
It's considered an Arrhenius acid because the dissociation increases the number of hydrogen ions in aqueous solution.
And another example of Arrhenius acid is hydrobromic acid or nitric acid.
Examples of Arrhenius bases include sodium hydroxide and potassium hydroxide. The Bronsted-Lowry theory of acids and bases. So Bronsted-Lowry theory of acids and bases took the Arrhenius definition one step closer. As a substance no longer needed to be composed of hydrogen or hydroxide ions in order to be classified as an acid or base.
So basically, a Bronsted-Lowry acid is a proton donor, and a Bronsted-Lowry base is a proton acceptor.
Conjugate acid-base pairs. A conjugate pair refers to acids and bases with common features. These common features include the equal loss or gain of protons between the pairs. Conjugate acids and conjugate bases are characterized as acids and bases that gain or lose protons, respectively. In an acid-base reaction, an acid plus a base reacts to form a conjugate base plus a conjugate acid.
The conjugate acid of a base is formed when the base gains a proton. Equation right here says that NH4 plus is the conjugate acid to the base NH3 because NH3 gains a hydrogen ion to form NH4 plus, which is the conjugate acid.
The conjugate base of an acid is formed when the acid donates a proton. In the equation, OH negative is the conjugate base to the acid H2O because H2O donates a hydrogen ion to form OH negative, the conjugate base. Neutralization reactions and titration. So neutralization is the reaction between an acid and a base in which neutral water is produced.
Titration is a laboratory technique that very accurately measures the concentration of a solution of an acid or a base. And the reaction between an acid and a base is referred to a neutralization reaction, since the more reactive H plus and OH minus ions combine to produce neutral water. When equal amounts of strong acid and strong bases are combined, we are left with a neutral solution, which is when the pH is 7.
Titration is a laboratory technique that very accurately measures the concentration of a solution of acid or base. It makes the use of neutralization reaction and the fact that pH changes very rapidly for neutral solutions. Yeah? No. pH scale. The pH scale measures how acidic or basic a substance is. The pH scale ranges from 0 to 14.
A pH of 7 is neutral, and when the pH is less than 7, it is acidic, and when a pH is greater than 7, then it's basic.
Yes.
Go.
So molarity. In chemistry, molarity is a concentration unit defined to be the number of moles of solute divided by the number of liters of solution. Molarity is expressed in units of moles per liter, and it is expressed in the symbol of the big M.
Molality is the number of moles of solute per kilograms of solvent, and it is expressed as a small m.
Thanks for watching Chem Talk with Allysa and Dawna.
Sponsored by Slurpee.